The science is telling us very clearly that what we're doing as human beings, just existing, just me coming on the train to visit you today to have this discussion, I've created some emissions. That's a good thing because it's allowed us to be here and communicate and do all of these things. But the science tells us now, right, understood, we need to move away from that now. That's the mitigation piece that we talk about. So we need to adapt to the changes in the climate and how that's driving different weather patterns that we're seeing, rain, heat, all of those different things, failing crops, migration. But that's a matter of us adapting to the change that is already in place. But we know the science now, so we need to mitigate against these damaging any further. And that's where your 1.5 degree, 2 degree scenarios come in. And that's always a difficult one for some people to concept, because to you or I, 0.5 degree is not going to make any difference at all. But if you're a migrating animal, if you're a coral, if you're a crop, that makes a huge difference. And that's where these big swings are going to come in. We know we've caused the problem. We need to create a society. I mean, these are big subject areas, but we need to create a society that can deliver what everyone needs in a fair way, but in a lower carbon way, so that we're not damaging things.
Hello and welcome to the Thriving Construction podcast. Today we have Martin Fahey with us from Mitsubishi. Martin, great to have you here on the show.
Brilliant. Well, no, thank you very much for having me, Darren.
So I think that there's probably a good section of our listeners that have never heard of you, but they've heard of Mitsubishi and the organization that you work for. So I was wondering if you might be able to just do a brief introduction and maybe just focus on the role that you've got at the moment and what that means.
Yeah, of course. Yeah. Mitsubishi Electric are part of the wider Mitsubishi Corporation. There's a clue in the name, as I'm fond of saying. So we manufacture products that consume electricity to deliver another product or service that a building may want. So heating is an example for a heat pump, but lots of other technologies such as lifts and escalators, factory automation, robotics, semiconductors, automotive componentry. So they're a business of very long standing, started in 1921. So we have not long had our 100th anniversary. And it's an interesting time for us as a business, because we're looking now at, what does the next 100 years look like for us as a business, making, developing, innovating in the sort of markets that we operate in.
Sounds like an exciting place to work.
It is. I find that it is very much so. Yeah, it's brave maybe to claim uniqueness, but I think we are unique in the breadth of products and solutions that we are involved in, and therefore that we can have a discussion about across a wider piece. So that discussion, that what I mentioned there about lifts and escalators, vertical transport within a building. How do we best integrate that, as well as then looking at how we control the wider building, keep it at a comfortable temperature and an efficient operation system as it is. So I think we're fairly unique in that with that broad array of solutions that we can bring to bear a really pressing issue, that we all know that we've got to make changes very rapidly on this agenda.
What is it that you do? What's your role in the company?
So I'm the head of sustainability for UK and Ireland. So that involves me working with a colleague in the UK. We are part of a big global business. So we look at how do we fit in with what the global business has stated to the market about what their net zero journey looks like. And there's been an announcement of that actually only this week, sort of hot off the press, about us revising our science-based targets to fit in line with the 1.5 degree net zero trajectory, which is a good step for us. So how do we work with the wider global business and address, adapt and certainly mitigate to make sure that our business is not adversely impacting on climate change? But then there's very much the UK specific and the markets that we operate in a post-Brexit world, and what regulation looked like for that, and how do we make sure we're ideally ahead of the curve on those things. And the third and vital audience for us as a team is our colleagues. Colleagues are going to be central to us in achieving our wider goals. They know their part of the business best and the demands and requests that they're getting. So, yeah, 3 distinct areas is the way I would describe my role at the moment. And I'm doing that for our UK and Irish offices, branches.
And what's your favourite part of the role?
I've always enjoyed the communication part of the role. Initially, there was some abject terror to that, to being put out front and find yourself sat in rooms talking with the likes of yourselves, Darren, with what the viewers can't see is cameras moving around in our face. That certainly wasn't what I envisaged as part of my future when I started my apprenticeship as a refrigeration engineer back in 1985. Yeah, that wasn't part of it. But yeah, I do find myself enjoying it. I think it's vital that we communicate and collaborate, most certainly. I'm sure collaboration will come up later in this discussion. And if I can be part of that and have the privilege of representing the company in these sort of forums and others, then I do really enjoy that, yeah.
In a previous life, I had a sales role, and my sales role took me into other businesses. And sometimes it felt as though I wanted to communicate with them, but they weren't interested in communicating with me. And so I'm wondering, do you how does that sit and feel with you, with the difference that you're trying to make within the industry, with the services that you've got, the desire that's behind that coming from the wider Mitsubishi organization, and then how that is perceived or received when you send an email or pick up the phone or reach out to your clients?
Well, as I say, there's been a real journey on this sustainability subject that we've certainly seen in my 20 years since I've been with Mitsubishi Electric. Very early on, sort of 15 years ago, we created a document and a, maybe rather grandiose at the time, we called it a philosophy. We called that Green Gateway. And that came from us having those discussions with various parts of the supply chain in the whole built environment. At the time, I think it's fair to say we were very focused on the contract part of the supply chain, and still are, and they're a vitally important part of our business. They're key to purchasing the equipment, installing it properly, maintaining it properly. But in that period of time, we were thinking, well, we'd like to take this discussion about how you could best apply a heat pump solution, for example, a ventilation solution, whatever it is, VRF. We need to take that further up the decision-making chain. And even back then, all those years ago, so I'm talking sort of 15 years ago, I think we could see that there was more need for us to have a defined position, but also a willingness to engage wider about how to best apply solutions for a more sustainable outcome. And I think that was well received. We were early with that sort of message. Net zero wasn't a phrase that was even contemplated at the time. I can't remember the first time I ever heard it, actually, but it certainly wasn't 15 years ago, that's for sure. And then we've gone along on that journey with our current prospective customers to say, well, how can we achieve this goal? We're fond of saying, and it was coined by a colleague of mine, that net zero is a destination that we all know what the destination is, but there isn't a map. So it's a destination, but no map to get there. If you make a decision today to turn left or right, you'll be on a completely different road as to where to get to net zero. So I'm fortunate enough to work for a business, a global business that recognizes they have a part to play in this, that they have very long and very complicated supply chains, upstream and downstream. And they are taking what I think is a very honest and pragmatic approach to how do we address our impacts within that supply chain for a company of our size. And that's where recent announcements, revised science-based targets and things like that come from. So I think when you're out in a head of sustainability role, you do need that senior support and buy-in. And I'm fortunate enough to work for a business that understands that, and they have a part to play in the solutions.
How long do you think that that's been embedded in their minds, this concept, getting on or forging the path to net zero?
Well, as I say, the 15-year period that I'm talking about there, that we have been talking about this sort of stuff, specifically in a UK context. The global business, and I have a UK position, so I can't speak for the global position. But I think they've been on a very similar sort of period of time, sort of pathway. They're very good looking very long term, as I say. So we're a 100-year-old business already, established in 1921, creating products as our president at the time described as for the good of society. Electricity in 1921 was, not as widely used and understood, I suppose, as it is today, most definitely. But it was an evolution of the company to say, well, we can see that's where the part of the future is. So that was their establishment of that in 1921. So now, 100 years later, we can see now that there's these big macro discussions going on. Is it an electric economy that we're going for, which of course we're very much behind? If something can be electrified, then we should be doing that. We should be doing that now. And the UK is if you look at the pie chart of where energy is being used and therefore emissions are being created, our demand, we consume an awful lot in buildings and in surface transport. And if you break that down slightly further in the buildings, a lot of energy use in the creation of heat. And that, on both of those markets, historically, certainly in that period of time, in that 100 years period of time, has been literally fired by fossil fuels. And we need to get away from those things. So it's very clear, if something can be electrified, then let's do it, because it can be applied today. The rate of change can happen today at the speed required. And of course, electrically driven equipment buys into future greening of the grid. Last year, we were 45% renewables on our grid, and that's only going to get better.
One of the things that you mentioned earlier on was Brexit. I know that there have been some concerns that I've heard from some of my clients that there isn't going to be enough, or there aren't going to be enough heat pumps around, partly because of Brexit, partly because of the supply chain issues that can exist within organizations like yourself. Do you buy into that?
Well, I'm slightly more optimistic than that. Certainly putting in another border is just another barrier that you have to cross for any business. Anybody watching this will understand that. It's another piece of paper at the very least that you have to fill in, or it's a misalignment with a tax regime or something like that. So, yeah, Brexit is an added complication. The UK then has a position whereby they can create their own rules and regulations. Europe are very much globally, the EU, I'm talking about now, are very much a leader in this setting of environmental standards and what is required, whether it be food or energy or, anything in their markets. So I think they will always be a beacon for us and others to follow, if you like. If we meet or exceed the European requirements, we've certainly got a solution that will be best suited around the world.
So do you think that there's going to be a supply chain issue then with getting the heat pumps into sites and into your clients?
Well, the UK is no different. So the UK has got very broad ambitions to install heat pumps because, as I say, they work, they're applicable today. The skills largely exist. Now, I'm not underestimating the skills challenge. We speak to a lot of people about that. We're training a lot of engineers, technicians, service people on heat pumps. But what we're doing is we're transferring their existing skills. So they already know how to install pipes properly, wire something properly, site something properly.
Yeah.
A heat pump is a different heat source to a gas boiler or to an oil boiler, to an LPG, whatever it is. So it's applying those existing skills, but we certainly need more of them. So I'm not going to make light of the skills shortage that is out there. But the thing I wanted to get to there, Darren, is we're not the only country that is making this change. So the UK is looking to shift from where we are now, domestic heat pump supply of 60, 70, 80,000 a year going in, to an order of around 600,000 a year going in. And then if we're to stay ahead of where we need to be at a rate of sort of 1 million a year going in, which is the rate at what gas boilers are going in, 1.2, 1.4 million a year. So we're at that point, that pivot point now where we need to switch away from dependence on fossil fuels. Easy for me to sit here and say that. Fossil fuels have got us all to where we are today in the Industrial Revolution and all of those sort of things. We have a very mature gas supply grid in the UK, but we need that. That was then. We know now there's a different way. Heat pumps are a proven technology, and we need to apply them at pace in the right way so that we wean ourselves off this dependence on fossil fuels.
There'll be people listening to this that will have heard of heat pumps, but be unfamiliar with how they work and why it's kind of different to a gas boiler, or even will kind of ask, like, why do I even need a heat pump anyway? Can you share your thoughts on why you might need a heat pump, and also how a heat pump is different from your combination boiler or your standard boiler that you'd find in a house?
So your standard boiler is a heat exchanger. So it burns gas to create heat, and then the heat exchanger puts that heat into water. The water for you to bathe, wash, do the washing up, take a shower, but also then pump through underfloor heating or radiators. And that's been the established way of heating in the UK for 40 years or more. And that's why we have an established gas supply network. Now, gas is now a problem. It's harder to get hold of. The nations who are in control of it are not necessarily the nations that we want longer term relationships with sometimes. But also, when you burn a fossil fuel, it's a one-time deal. You burn it. It releases its energy in the form of heat, which is what we want as a society. It's a one-time deal. That's burnt. It's gone. Then creates emissions in the form of CO2. So you've burnt a fossil fuel. CO2 is released into the atmosphere. Also, different particulates and things. So it creates, depending on what you're burning and how clean the system is that you're burning in, creates air problems. That's another subject area that's being talked about a lot. But the top and the bottom of it is a finite source that releases a lot of emissions, and we need to move away from that. That makes sense to do that. Now, how do we move away from that? Well, one of the main solutions to be able to do that is a heat pump. And you asked me to explain how a heat pump works. Well, the most common way to describe it is it's like your domestic refrigerator or freezer at home, but in reverse. So it's the same system. That at the heart of a heat pump is a process called a vapor compression cycle. So 4 main components: an evaporator, a condenser, an expansion device, and a compressor. Luckily for me, trying to explain a heat pump, they all do what their name tells you they do. So the refrigerant goes around this system, and what it does is it changes state. So if you remember from your physics lessons at school, when something changes state, water is a common one, changes from a liquid to a vapor in the form of steam. It's absorbed heat to turn that water into steam. And the same happens in reverse. As you take energy out of that water by cooling it down, it turns into a solid. Now, we can't pump a solid. No one can pump a solid around. So a vapor compression cycle makes the most of that physics of changing state. And we do that using a liquid called a refrigerant. And that refrigerant would boil. Now, we're used to boiling things at high temperatures, like a kettle boiling at 100 degrees, because that's what temperature water boils at atmosphere. But a refrigerant doesn't. A refrigerant would boil at a far lower temperature. So that's the bit that to understand. And that's why when people say, but how can it possibly absorb heat when it's cold outside? Well, if the refrigerant looks to change its state and turn from a liquid to a vapor, that would typically want to do that at around minus 40, minus 30. So in theory, any temperature above minus 30, there's potential heat in that for a heat pump to be able to grab.
So minus 30, you're talking minus 30 degrees Celsius here?
In Celsius, right, yes, great. Most definitely, yeah. Now, in theory, we don't operate down at those sort of levels, but minus 20, minus 25, with modern heat pumps, with modern refrigerants, they certainly can operate in those areas. And supply temperatures, water temperatures at the other end. If you can supply water at a lower temperature, then the efficiencies get better and better. It's a bit wordy, I suppose, but I've lived with heat pumps for a long while, but that's essentially what we're doing. Changing state of a liquid via known technology, and that absorbs naturally occurring heat from the atmosphere. And most of these are air, what's called air to water. And that's why they're deemed as a renewable technology, because as long as the sun comes up every day, that's creating some heat that is in the atmosphere that a heat pump can exploit.
No, that's perfect, because there are people that listen to this podcast that are not as familiar with things like heat pumps as you are.
Yes.
So that's great. That's a fantastic explanation. Thank you. I'm wondering where you see the future of heat pumps. So the technology is there, has not been it's been there for a considerable amount of time, but has not been maybe as long as the concept of burning a fuel to get heat. I'm thinking here, logs on a fire, gather round, stay warm.
That's right. Yeah.
So where do you see, or how do you see? And I'm not asking you to give away any secrets here of the organization, but how do you see that technology being built as we move forward?
The way I explain when I'm asked this question is to, in your mind's eye, is to imagine 3 squares on a piece of paper in front of you, and the left-hand square is sources of heat. Now, that could be what we've already discussed, naturally occurring sources in the air, in the ground, in a water source. Or it could be what historically would have been deemed a waste heat source. So there would have been some sort of industrial process, or nowadays a data center, or these cloud computing centers that are built everywhere. Those are all kicking out amounts of heat. So sources of heat on the left. Forget the one in the middle at the moment. On the right, we have a requirement for heat. In the jargon, they're called sinks. Sources and sinks. So they are broadly in 2 areas, space heating and water heating. So that you've got a big demand for those in the UK, for both of those. The technology that links a source with a sink, middle square, is a heat pump, a big heat pump, a small heat pump, a networked heat pump. So increasingly, as we look at buildings individually, we have technologies that can move heat from one room to another. So we could be in this room and be a net exporter of heat. The room next door might have heat to spare as well, same as us. So that's 2 rooms. And then the third room is actually, please send me some heat. So the technologies nowadays are very good at heat is the goal here, is grabbing that heat and moving it to where it can be best used. Don't waste it anymore. Back in 1980s, when I started, most equipment was cooling only equipment. To me, a heat pump back in those days was a product that could heat and cool. So we've developed that that language now, and it's being talked about. So yeah, heat pumps are the technology that can create this change that we need by grabbing heat, moving it, upgrading it in its process, and then using it somewhere where that heat is required. I think you talked about, the different types of buildings. So as we look at multi-story buildings, people often say, well, how can we do that? I mean, they look like what they look like. So we don't want heat pumps hanging off the side of a big tall building, do we? Well, no. But we've been heating those buildings with heat pumps for a lot of years, certainly in my entire career. But that's come about as a byproduct of those buildings having a cooling requirement. And that's that technology, what we call variable refrigerant flow technology, that moves heat around a building. That's a heat pump. It's just my 3 square analogy. It's just a very complicated heat pump that can link 30 different rooms that are all doing different things and having different requirements to another 30 rooms, or a demand for hot water, or a swimming pool, or whatever. So it's a pivotal technology, really. We used that language back in Green Gateway in the day, because it really is. It's pivotal in that of what it can do.
Sounds like you've got an engineering background, Martin, just by the way that you're speaking. Is that right?
Well, I've got an apprenticeship-based background. I started in 1985 when I left school. I was just shy of 16, and I knew I wanted to do something within an engineering field. And I found myself being a apprentice refrigeration engineer. And yeah, the rest is history, as they say. I'm still in that industry now, and I certainly would not change my apprentice route to where I am now, because the concepts and the engineering and the wider things that I learned from other skill sets at the time, from the electricians, the pipe fitters, the plumbers, I think has stood me in good stead all the way through. So yeah, very much an apprentice practical background, Darren. Yeah.
Where do you think that stemmed from? Were you quite young and into playing around with things and understand how things are taken apart and put back together? Did you have a parent or a family member that was into that type of thing?
Very much so, yeah. My uncles, my grandfather were all engineers, were all apprentice trained. And yes, I was always fascinated by how things worked, taking things apart and how they worked. And I'm sure you've heard this before, Lego was a major thing for me at the time. And it was often something that I was bought, at special occasions, and that more technical side of Lego. So I think that sort of background, is definitely what took me to it, a vocational, wish to work in engineering. I had no idea about refrigeration, how it worked. I walked into my first plant room, which was supplying a single space that we were maintaining. It was 500,000 cubic feet. I remember the number, and we were maintaining it at -40. And there were these big machines that I learned were called compressors, whirring away, and I had no idea how it worked, but it just seemed endlessly fascinating. And luckily enough for me, the chief engineer could see that, I think, and offered me the job.
So it seems like from a young age, you're interested in building things as opposed to taking things apart, or was it a mixture of the two?
Mixture of the two. You've got to take it apart to find out what's going on the inside, haven't you? Yeah. So I was lucky enough to be able to take big compressors apart and rebuild them and put them back together and learn that way, and learn with some, time-served engineers who were only too willing to show you how to do things. If you were willing to listen, they were willing to teach you, and so, as I say, I wouldn't change that for the world. It gave me a good grounding.
I've spoken to quite a few people that are into Lego, so I don't think there's any shock or horror.
No shame in that. Yeah, yeah. It's just amazing. Just that ability to have a box of bits and just create something out of it, I suppose. And yeah, I've enjoyed it ever since.
What's the most obscure or creative Lego thing that you've built?
Well, I could go by this. I didn't think this was going to go this way, Darren. You were going to get this bit of detail out of me, but my family were good enough to buy me the Saturn V rocket, the rocket that took man to the moon. Lego do a model of that, and it took a lot of hours here. I had to really concentrate on it, but it was just a huge joy to work it out and get that built. Yeah.
And has it got its designed, treasured place in your home?
It is. That's the problem, because it's a meter tall. So where do you put these things? So you run out. I have a very patient, wonderful wife who is able to accommodate these things. But yeah, so it does take up some space.
That's good. That's good. I love that. I think it's always good to reflect back on things that have influenced us of where we're at now, and just kind of take a moment just to give some appreciation to that. You mentioned that your uncles were quite fundamental in terms of you developing in that way. How would you say that other work colleagues, and who has there been that within the professional realm that's shaped your career and helped forge who you are?
Well, I mean, if I go right the way back to the beginning, I worked, as I say, I was an apprentice to a refrigeration engineer, time served. Vince, hopefully he's watching. I hope you're doing well. And yeah, he had, just so much practical knowledge of how to apply what you were learning in a college environment. So it was the great advantage for me, I think, was I had a job that was working with 17 other engineers and technicians who all had their own different disciplines. But every single one of them was willing to teach you and talk you through something, whether it be welding or, whatever it was. And that took me on from that stage. And I, like you, Darren, found myself in a sales role for another manufacturer back in the day. And it came after I'd done product support roles. I was helping the sales guys who were on the road, generating quotes for them, just very similar to how it's done now, still now, where you learn all those bits and bobs. And then, I thought, I can do this selling thing. I'll give it a go, and out I went and got keys and a car and an A to Z, as it was back then. That was your area. Go out and sell some of this stuff. And as I think I've already mentioned, it was applying what I'd learned. It certainly wasn't a hard sell. It wasn't your classic sort of double glazing, sat on someone's sofa until they signed something sell. It was helping them because they had a project. They wanted a solution. How could this be applied? Working for different manufacturers, new things would come along and you would have to go out and explain those. I think if I was telling myself, my 15-year-old self, something now, it would be to learn to present and speak and sell a concept, and because that certainly wasn't taught to me in the school I went to back then. But I think that's a skill that everybody has to have, don't they? Because selling, I always enjoyed my time selling, because the best idea in the world could sit in a drawer, couldn't it? Unless somebody said, well, I've got to go out and tell people about this now. So that's what I saw it as, was working with people, often at that time, a lot older than I was, who'd been doing this a long while, and saying, have a look at this, or how can I help you with that? And I think the key to it really was, for me, certainly it was deliver on what you said you were going to do. If you was going to say to someone, I don't know the answer to that, I learned pretty quickly, that's not a problem to say you don't know the answer to something. But if you say, I will get the answer to you by next week, as long as you do that, you make sure you do that, you've learned something, and they know they can rely on you. So
I think that's a really interesting point. Kind of 2 points I've picked up on there. One is the ability to tell a story, or to bring life to an idea, so someone can understand what that idea is like and it's real to them. And then that second thing, which is that credibility, which is telling a story which is authentic and that is true and that is real and that can be relied on, as opposed to a fable or
absolutely
something that's not true. And it's like, well, you he's a storyteller. Don't worry about that. He's talking nonsense versus absolutely, the things that come out of his mouth, absolutely credible, and it's great. I can rely on them. I know that he's going to deliver on that. And I think that's what we all face in life, irrespective of the position that we're in or the company that we work for. We've all got these ideas and these concepts that we need to tell one another.
That's right.
And I think that it is a skill that probably could be focused on more in schools. Maybe I can focus on it more with my own family and my children, is how do you take a concept and help somebody to understand that? But then how do you make sure that you are true in the things that you're saying and that you can be relied on so that that person can keep coming back to you because you're adding them value?
Exactly that. Yeah. I mean, what I was always told many years ago, that, the most valuable thing is not necessarily that initial sale. It's someone who's willing to come back to you to buy something again, that repeat customer basis. And that's only gotten more, choice has only got more diverse for all of us. And, we carry a supercomputer in our pocket. We can, if we don't like one supplier, one bank, one shop, we look somewhere else, don't we?
Definitely, yeah.
And that's exactly the same with what we're talking about here in these solutions that we have ahead of us, because we can't expect Mrs. Jones of 22 Acacia Avenue to know those things. And why should she? She's running a household, raising a family, they're out working. They want efficient and ideally environmentally sound heating system in their home. But let's be honest, what they primarily want is one that's reliable and works for them and is cost effective, that they can afford. And, I don't think all the answers are in place for that just yet. Whenever you make this big shift, and we've done it before, we talked earlier about that solid fuel time of our life. And that's what we were doing. The coal man would deliver you a back, filthy, dirty, and deliver you a sack of coal. You knew how much it cost. You knew how long it was going to last. And you actually were physically connected, because each lump of coal you put on the fire, you knew you weren't going to get back until the coal man came. Gas came along with this big promise of, well, it's cleaner. Well, yes, it is. It's cleaner than coal. And it's cheaper. We'll get it to you cheaper. That was the promise at the time. But of course, it was all sat in the North Sea. And then everybody else was sat in front of their coal fires. So there was a huge national effort went into connecting that energy source with the homes. And now we have a very mature gas network in the UK that we've, as I said earlier on, that we've all benefited from for a long, long time. But now we're at a point where we need to shift again. The science is telling us very clearly that what we're doing as human beings, just existing, just me coming on the train to visit you today to have this discussion, I've created some emissions. That's a good thing, because it's allowed us to be here and communicate and do all of these things. But the science tells us now, right, understood, we need to move away from that now. That's the mitigation piece that we talk about. So we need to adapt to the changes in the climate and how that's driving different weather patterns that we're seeing, rain, heat, all of those different things, failing crops, migration. But that's a matter of us adapting to the change that is already in place. But we know the science now, so we need to mitigate against these damaging any further. And that's where your 1.5 degree, 2 degree scenarios come in. And that's always a difficult one for some people to concept, because to you or I, 0.5 degree is not going to make any difference at all. But if you're a migrating animal, if you're coral, if you're a crop, if you're that makes a huge difference. And that's where these big swings are going to come in. So we know we've caused the problem. We need to create a society. I mean, these are big subject areas, but we need to create a society that can deliver what everyone needs in a fair way, but in a lower carbon way, so that we're not damaging things.
What does it mean to you to be part of Mitsubishi, specifically in the area and leading the department that you are at the moment?
I certainly have, and I don't mind using the word, I certainly have a sense of pride in being in the position that I'm in, most definitely. it does afford me the privilege of these sort of opportunities, of sitting in and talking to other experts like yourself. But I'm very fortunate to work for a business such as Mitsubishi Electric, who, to say, gets it really. They understand their position in all of this. We have some of the products, heat pumps, as I said, big ones, small ones, whatever they are, that can make the sort of change that we need at the pace required. And I was thinking about this a little bit on the train on the way down, so I thought you might ask about that and our place in things. I think if you look at the span of things for me, just for me at the age I am, I'm 55 this year. So I started in a technical facing apprenticeship, happened to be refrigeration engineering in the mid-80s. You know, we're now sat here in 2024, 2025. That period of time, you know, we've seen huge shifts in computing, in data volumes and acquisition, in what the science is telling us is good and bad. So we know what's bad. There's no discussion anymore about what's bad, is it? We've got to stop burning stuff. Simple, right? 40% of our electrical energy is coming from renewables. So far, that will only grow and grow and grow. So the next 100 years, 50 years, you know, other people will be taking that forward. So yeah, I don't want to get too grand on this. I'm very fortunate. I work for a very forward-looking company that is making some of the solutions that are making a real difference today. And I'm just delighted to be trusted enough, I suppose, to come out and tell that story that we were talking about.
Mm. What's your hope then for the future?
Yeah, well, if we have two boys. One's just left university and he's now working as a veterinary surgeon. Hugely proud of him. He's put 6 years work in, and he's out there and doing it. I mean, he's doing an amazing job. So yeah.
I've heard actually people say that to become a veterinary surgeon is more complicated and difficult than to become a doctor.
Yeah, that's often the case, yeah. If Liam was here, he'd probably tell you that quite clearly as well, most definitely. But it's fascinating to hear him talk and how he applies things and what he's learned. And I often say with him, he'll never work a day in his life, that lad, because he just enjoys. He's got a true passion for everything that he does, and he wants to keep learning and make a positive difference and help and do those things. And our younger son, a couple of years younger, Luke, he's doing mechanical engineering and he's doing his year in industry at the moment. And again, you know, the world's his oyster. When you talk to him, you know, quite challenging discussions, he'll come out, well, what about this? What about that? Does that work? Are you measuring our heat pump's efficiency? I get those sort of questions over the dinner table now. So it keeps you intellectually stimulated and challenged. And that can only be a good thing. Yeah. So I'm hugely proud of them and everything that their mother, Sarah, has done for them to set them up for that. Yeah. So I'm very lucky in that regard.
And how does that feature then into terms of your work, how you've brought them up, the ethos that you've had as a family? How does that all mesh together?
Yeah, I think we have a very good work ethic. I think my father gave me that from an early age, which was, you know, no one's going to give you anything necessarily. You have to get out and go and work for it. And so I would certainly credit him with that, with giving a good work ethic. And I think my wife's morals and support and sort of wisdom in things has just created a situation whereby we've got two, I would say this one, not everybody says it about their own children, but, you know, we have two wonderful boys who, you know, striking out in the world now, and I think can do amazing things. So I'm just immensely proud of them. Yeah.
Good. How do you see your team?
Well, our team is two people in Mitsubishi Electric UK. Obviously, we're part of the wider Mitsubishi Electric is something north of 160,000 people. You know, it's a big old machine that's out there. We're two people in the UK, and we're two people, though, with a dedicated brief and ability to be able to concentrate purely on sustainability. Mm-hmm. And as I think I mentioned earlier, how how we apply what the global business has told the world that they're going to do from a net zero target wise, science-based targets, global UN solutions, etc. And then our UK marketplaces that I mentioned earlier, so I don't need to repeat that. And the important element in all this is how do we take our colleagues on this journey as well? Because there's a huge amount of knowledge in a business like ours, and we need to tap into that and learn from their experience about what works and what doesn't work, where the waste is. Look in all those dark corners about where we're wasting things and how we can do things more efficiently. And we're doing a really good job on that. My colleague Jack is great. He's younger than me and very much, fired up in that desire to want to make a positive difference out there in the world. And it's great having people like that around you, because they, and as I've already said with our boys, they keep you on your toes, they keep you honest, and they keep you pushed along. And yeah, I'm fortunate to be where I am.
Talk to me about the efforts that you're going to help the industry understand the embodied carbon that is within heat pumps and all of the other elements and components that go on or go with actually installing a heat pump in a property.
Yes, of course. So we as a business historically and continue to spend a lot of R&D effort, a lot of engineering expenditure. How do we make a product that is the most operationally efficient through its life? If we found just 1% energy efficiency saving in a heat pump, let's stick with domestic heat pumps, that 1% would be in play every hour of every day for 15 years that it's in situ. So operational efficiency has always and will continue to be vitally important. But as we see operational loads dropping, buildings getting more thermally efficient, so we're building better, we're refurbishing our existing stock better, they are requiring less energy to keep themselves comfortable, profitable, pleasurable spaces to be in. So that operational phase as a whole of a building is shrinking. So that's, to pick up on your question, Darren, is where things like embodied carbon come in. So that looks at the entire cradle to gate of, so all the materials that go into that product from all your supply chains into a factory environment. It's manufactured, and then you've got a product that's sitting at the factory gates. Then you've got a cradle to grave approach, which is obviously it's not doing a lot sitting at the factory gates. It is delivered around the world. It's installed. It's operated through its life. At the end of its life, the materials are recovered. So that's cradle to grave. That's where your embodied carbon comes in. So how do we calculate all of the different carbon impacts for the different materials and processes in that finished thing that is a heat pump? Now, we worked with CIBSE, Chartered Institute of Building Services Engineers, and their consultants at the time, because a lot of work had been done on the materials for a building, the bricks, the facades, even the paint, the plasterboard, all of those sort of things. But a lot less to none had been done on the mechanical services to understand what are the impacts of those. What's good, what's not so good when it comes to embodied carbon. So we were interested in that and more than happy to work with them. And we shared some of our products. We worked with our factories who initially were nervous of this approach. It was the way I explain it is it's like asking them to share their ingredients list with the world. And we worked with our factories to get them to a comfort level whereby why this data would be a good thing for everybody. And then CIBSE created a document called Technical Memorandum 65, TM65, and that created a framework to be able to calculate embodied carbon for equipment like ours, air conditioners, heat pumps, whatever it is. So we were delighted to work with them in the creation of that. We have since that point created hundreds of individual data sets for our products, which are available to anybody. They can go onto our digital library, download them, and look and see, well, where are the impacts on let's stick with the heat pump. Is it the material in the heat pump? Is it as we're often asked, is it the shipping of it? Well, if you've made it in Japan, that's terrible, isn't it? Mm. Well, actually, it's not until you crunch the data that you realize that actually the transporting of something is really a very small element of the whole. Of course, if you can cut that down, then you cut that down. And we're fortunate we manufacture in the UK. We have a factory in Scotland. And then you get to look and see, well, where are the impacts, the embodied impacts of a product like a domestic heat pump? And when you do that, you see that the refrigerant that I explained earlier, with vapor compression cycle, we need a refrigerant in the system. The refrigerant is a substantial part of the embodied carbon because you have to assume that some of the refrigerant will leak. Now, that isn't the case with a hermetically sealed system like that, but the method says you have to calculate some leakage. So the refrigerant that you use has quite an impact. And we wanted to be honest with that. So it could have been just a number on the data sheet that we supply. But we felt that wasn't clear enough for consumers, other engineers who were making those decisions. So we show our embodied carbon with all the materials and all the logistics, and we show on the graph at the front the refrigerant separately so that anyone can make that comparison. And what that teaches us then, it's a long way to get around, what that teaches us is then as a business, we can understand, well, when we're creating a new product for the market, such as our latest Ecodan heat pump uses R290 as a refrigerant, that has many of the characteristics of its previous refrigerant, but a far lower, what's called global warming potential. So if it ever did leak. So the embodied element of that machine drops quite drastically. And it's really through us doing that that pausing, I suppose, taking the time to really analyze, be forensic about a product that allows you to make those sort of engineering decisions and go out to the market with a solution that we feel's the right one.
Seems like two things came out of that process. One is you understood what the embodied carbon was. And then the second thing is by understanding what the embodied carbon was, that then enabled you to make changes to improve it.
Exactly that, yeah. Don't get me wrong, Darren, I don't think we're at a position yet because we're still early in this journey and lots of other manufacturers are doing their work on understanding where their impacts are. I don't think we're at a stage yet where a direct comparison is being or could even be made, product A from us, product B from somebody else. So, but as those data sets build, that will certainly happen. From us, purely as a company innovating and creating the next generation of products, it's really useful for us, yeah. Because another thing that we do is we have a really good look at what does it mean when this heat pump is finally at the very end of its life. It should be seen as a repository of some materials, X amount of kilos of copper, aluminium, steel are sitting in that box. So we don't want to just discard that. We want to make sure those materials are fully recovered. And we invest quite heavily. I've been fortunate enough quite a few years ago now, to see this process in Japan, whereby we have a process called hypercycle systems that looks at the dismantling end of life stage of a piece of equipment like ours. And how do we get as higher recovery rate as we possibly can for those materials? We then pass those materials to a second system called green cycle systems, which works on their purity and the quality of the materials. And then we're happy enough for those materials to come back into our supply chain to make the next piece of kit. But the point I'm taking a long while to get to is, having those facilities in our ecosystem, if you like, allows the engineers who are creating tomorrow's, the new piece of equipment to really understand what it actually means, because one day it'll be an old piece of equipment. So those engineers get seconded and they go off to the recycling plant and they learn, well, oh yeah, I was going to connect this bit to that bit, but I can see now that that's really awkward when it comes to end of life. So it is creating a true whole life cycle discussion across our engineers, and we offer a recycling system within the UK, and we take that very seriously, and I know it's well received by the contractors. Yeah.
Martin, I think we're now at a point where we can go to the demolition zone.
Okay.
Are you ready?
I think I'm ready, as I'll ever be.
Let's do it. Okay, we are back here in the demolition zone. Martin, you have created a series of low-level items, low-level things, but you've positioned them in a circle. At least in my eyes, anyway, it looks like that's the case.
Yeah, your eyes are not deceiving you. Yeah, don't concentrate on the low-rise, high-rise thing. But what I'm trying to pick up on here, because I think we only briefly talked about it in our discussion, is the need for collaboration. No, on this journey to net zero, as I explained, destination without a map, we have our part to play in this. We're manufacturers. We've got to keep innovating, creating those products that deliver what the market requires and what the science tells us is required. And that's our place in this, I think, is to go away, carry on investing and innovating. But, that's one part of it. We're not the consultant. We're not the architect. We're not the contractor, vitally the contractor who's actually going to lay their hands on this piece of equipment, install it properly, maintain it properly, and at the end of its life, make sure it's handled properly and we get all those materials back into the supply chain. So what I've tried to represent is that collaborative approach, is the fact that we're all part of a ecosystem, I think is the word I'm looking for, whereby we all have our part to play. That analogy I said earlier about the destination without a map, play our full part in this transformation journey that we're on. And my optimism levels remain high, really, in that regard, because I do have it in the position I'm in, some really optimistic, open-ended discussions with contracting, big building firms, big end users that say, look, Martin, we've made our pledge. You've made your pledge. How are we going to make this work now? Mm-hmm. And, some real thought-provoking stuff. So I've tried to represent that in the blocks that you gave me.
Love it. That's great. So to sum up, I think what I'm taking away from this is that the myth would be that we cannot do it on our own.
Absolutely.
We are not an island. I mean, physically, the UK is an island.
Yeah, metaphorically, yeah.
But we are not an island. We can't do it on our own. The task in front of us means that we need to come together. So the myth that you're busting is we can't do it on our own.
Absolutely, we can't do it on our own. One of those will be government. Government, they're the only ones who can pull certain levers. Manufacturers, we know our place. Keep innovating, keep investing, keep bringing those solutions to market. But they've got to be designed, applied properly. And as I say, at the contractor side of things, vital, installed properly, maintained properly. So yeah, let's work together and rise to the challenge. And because there's a lot of opportunity out there for us as well.
Because we need to work together, Martin, let's just destroy the myth.
Yeah, get rid of it now.
However you want.
Right, the myth is gone. There you go.
Nice. That's fantastic. Thank you. Thank you.
No, thank you.
Just as we're speaking there, I'm wondering, who is it that you collaborate well with? Who do Mitsubishi collaborate well with?
Well, I think we've got a good history and continue to forge, really worthwhile long-term relationships with end users, whether they be retailers, hotel chains, whoever they are, end users, and those in that supply chain who are vital to building them, designing and installing. So I think we've got a very good history in forging collaborative relationships that are long-term and hopefully beneficial to both of us.
And this is a tricky question. We may delete this question, but it's a tricky question. Who is it that you want to collaborate with, but for some reason it's just not working, or you can't find out why it's not working? Who do you want to collaborate with?
Yeah, that is a tricky one, that, isn't it? I think, well, let's go straight for the top. Government. We're not a business that's into direct lobbying, and I don't ever see that changing. We work with some really good trade bodies that are out there, Heat Pump Association, BESA, BEMA, people like that, whereby we put what we feel is our knowledge and expertise into those environments, and whereby then that is a place whereby the politicians can come and seek, some good consensus. And I've always said in my time there, we've always remained pragmatic. So if something won't work or it's really just wrong, we'll say so. There's no point saying any other for some tiny bit of short-term gain or one project. We've got to be pragmatic, as my model hopefully demonstrated. We haven't got all the answers, so we've got to seek useful collaborations on this journey. And as I say, I remain optimistic. I'm sure we can get there.
And then what would you say to somebody that's listening that you really want to collaborate more with? What would you want them to know? What would you want them to do? How would you want them to approach you?
Well, get in touch. You will find us being a company and a set of people within that company that are open to new ideas and a new, hopefully, different ways of looking at things. I find myself in the position I'm in, talking with MPs, current and past MPs, and members of the Lords and their advisors and technical groups. And, not everybody, of course not everybody, but the vast majority of the time people are set to receive. They want to learn and they want to understand what is the right thing to do. How do we make this transition in a fair and equitable way for everybody, and make these positive changes, so that you were kind enough to ask me about my family, so that my family, your family has got a sustainable planet to live on off into the future. I know that's a big lofty goal at the end, but, collaborate, share. And I think, I don't think that anybody who makes an approach to us in that regard, they tend to get a positive response. We can at least have that discussion, can't we? That's not costing us anything, and we might learn something.
Martin, it's been a pleasure to catch up with you. Appreciate you coming in and sharing your wisdom, your perspective. But I just want to give you the opportunity just to give any last thoughts as we end the podcast. Is there anything that's on your mind that you want to disseminate or give as a passing thought to the listeners?
Well, from a personal perspective, I think we've got to be very careful with the messaging that we give out to wider society and other countries and other territories that are going to have to go through this change as well. When you listen to the news like I did this morning, and it talks about, we can't quite spend that much, we'll spend this much, we're going to say yes to more oil and gas. The language we use is vital. People aren't daft. They understand. They've got their own challenges, working, paying the bills, raising their families, doing all the things that we all have to do. But they're not daft out there. So let's be careful in our language, and let's be collaborative and long-term in our thinking. And again, I think we can do this.
Pleasure, Martin. Thank you very much.
Thank you.
I'd like you to do me a favor. And I don't mean here just to ask you to subscribe and to follow, but what I'd really like you to do is to share this podcast with as many people as you think would benefit from it. I would love to maintain the quality of people that are joining me on this podcast. And so in order for me to do that, I really need your help. It could be somebody that's looking to get into an industry, but they're not quite sure what industry they want to get into. Maybe it's a teenager that is just finishing their GCSEs or starting A-levels. Maybe it's somebody that's doing an English degree at university, but is not quite sure what they want to do with that degree. So I invite you just to share this podcast with as many people that you know so that we can grow this community, so that we can maintain the quality, engaging conversations that we're having together. Thank you for your help.